Okay, welcome back. So today we're gonna do day 6 of Advent of Code 2015. Let's see how that'll work out. And well, I finally created an automation to create a new day. Awesome. Day 6. So because our neighbors, or my neighbors, keep defeating us in the holiday house decorating contest year after year, you've decided to deploy 1 million lights in a 1000 by 1000 grid. Okay, grid. Usually, if there's a grid, you could either set up an array or two-dimensional array that has each point. Or what I like to do is use a dictionary or a set and then have it there or not. So I don't have to put 1 million lights in there. I can have just those that I need. I guess we're gonna go that way. Let's see. ID lighting configurations numbered from 0 to 999, each direction 00. Include whether to turn on, turn off, or toggle various ranges. Yeah, so basically we just need to store which one are on and which one aren't. To defeat your neighbors this year, you have to do is set up your lights by using introduction Santa send you in order. Okay, that seems quite nice. Get our puzzle input. So, okay, it says toggle 461, 550 through. Okay, so let's see some test cases here. Turn on 00399, turn on or leave. Let's just add that one as an input string first. We have an array of strings here. And we're gonna say first components separated by \n. So we have that print input, run it. Should actually turn on 00 through. Okay, so for row in input lights. I'll just use a set of. I have a point2d already, right? Yep. Set of point2d. So point2d is from day 3. It's basically just x, y, and it's hashable. That's why we can use it in the set. Okay, now we need to parse the input. I'm just be quite lazy actually, I guess. I'm gonna just say commands is equal to row dot split. Split is actually faster, but I'm gonna just do components separated by space, so I have a proper string and not a string slice string. Oh no, it's called. All right, and let's just basically do that up here. Say components separated map components separated by this. We have that. What are you complaining about? Then we have commands. Do a compact map here. Call that row. Make it nicer. Then we say guard commands.count equals 1, 2, 3, 4, 5 equals 5. Toggle is also one word, right? Turn off, turn. I guess we do it differently. We just stick with the string. Okay, now we can say if commands say card commands.count bigger than 1, 2, 3, 4, bigger than 4, because that's toggle, else continue, and then we can say switch commands 0 case turn on, case turn off, case toggle. In that case we say fatal error to be implemented, Let's go with, which one do we have? Turn on. We have turn on at first. So when it's turn on, we can say start range is equal to commands position 0, 1, 2. So 0 is turn on. Then we have that. Start range string components separated by comma, and then we say assert commands dot start range string dot count equals to 2. Just assert here. Well, basically let's also assert here, so we can see if something's wrong immediately. What's the problem with that switch? Oh, must be exhaustive. Default break. Just break. So it's also going to be quite ugly today, but we're used to it from day 5. We're used to that, so nothing new. We just say start range. Oh, we have that. Okay, so we say from x is equal to int start range zero, from y. You should never force unwrap actually, but in that case I want it to crash quickly. Let's rename start range string to start. Let's keep it that way. Copy that. Use the same for end range string 0.0, 1, 2, 3, 4. Place 4. We use the end range string here. We say and x, end range string, and y, end range string 1. And then we can say for y in from y and y. And x can say turn on as lights, insert point to the x, y. Let's give that a try. Seems somehow reasonable. See what happens. Assertion failed, Swift 26. Yeah, because it's not equal to 2. Let's print lights afterwards. Print lights. That's dumb. Now it should run. It's empty. That's not what I expected, because we're turning on 0 through 999. Say print start range string and range string. It's not a string, but oh, we don't even get there. Oh, yeah. Thing is, that's both the same. So we have case turn. Where commands 1 equals on. Some pattern magic fool. And that time commands on equals off. So that's the case if we have first turn, then on. That's the case if we have turn and off. Let's see what happens now. It's printing quite a lot. Guess it's somehow working. I don't want to print that. Okay, so that's turn on. You can use the same logic for turn off. Basically, we can just reuse it and then say if commands 1 equals on, and we do that. Else if commands 1 equals off. I know some people tend to hate else if. I just want to make sure if there's something else we don't expect, we can just remove. Yeah, so basically if there comes anything, if it's not on or off, I want to make sure that we don't do anything then. So that's why I have the else if here. We can remove that one. We can remove that one. And now we can turn it on. And if we just copy that and say turn off, then print the lights count, it should be 0. Let's see. Yep, nice. Lights count is 0. First 10,000 and 0. Okay, let's remove that. So we have on and off. Now the only thing missing is toggle. Let's just copy that over to toggle. Like, toggle is basically the same, except, you know what? Yeah, toggle. The first difference in toggle is that that's command 1 and not 2. And that's 3 and not 4, because it would say toggle. And then we say if lights contains just get that point here. And we say if it contains point, remove, don't add, no, remove point. Now we can say else, insert. It's no exact match, lights contains. Do you actually need the member? I don't think you need the member. You can just say contains. Yeah. And insert. Just don't create a new one. Just use point. And well, let's see. What do we have? Would toggle the first line. 1,000 lines. new one. Okay, that would toggle that. Let's see if we print it, what happens. Guess 1,000 or something like that. Yeah, 1,000 makes sense. Yeah, well, let's see what happens. I have no idea if that's the right thing we are doing, but let's see. Oh, I don't want to print it every time. Just want to print it at the end. It's actually quite heavy what we're doing, so I guess there can be some stuff optimized. I don't think that's the correct answer. That's the correct answer. So problem is we're actually iterating through everything we could. Like what we could do, what would make that a lot faster, is don't insert all of those things. Like either build a set and then with from the ranges, or we could also just add ranges and then calculate what's there and what's not there. So basically just have ranges in there, not each point, but I'm too lazy to do that now. You can do that if you want to do it. Do it. Apparently when you realize you mistranslated Santa's messages, the light grid you brought actually has individual brightness controls. Each light can have a brightness of 0 or more. The lights all start at 0. The phrase turn on actually means that you should increase the brightness of those lights by 1. The phrase turns off decrease by 1 actually means that you should increase the brightness of those lights by 2. Okay, let's just copy that over to day 2. It's actually not, I guess, it's not that hard, I guess. Famous last words. So we're not gonna have a set, we're gonna have a dictionary of point2d int initialize it empty, and now if it's on, we're gonna say light. We're gonna just use the point again. Point2d is equal to lights point default 0 plus equals 1. Default 0 is equal minus equals 1, and then we're going to say let cur is equal to that one, and then we're going to say lights point is equal to max 0 or cur, because we don't want to go below 0, we just add the max, because if we don't use that one it would go below 0 and we would have negative numbers, which we don't want. What does toggle say? Phrase toggle actually means that you should increase the brightness of those lights by 2. So we can say here, every time we can just use that one, put it in here, equals to 2. And now what we can do here is reduce lights dot values, reduce initial result 0. Let's see if Xcode actually, if Visual Studio Code is actually better than Xcode. It doesn't do auto closure stuff well. But hey, so let's just run it with our input and see what happens. I am quite confident. That's why I'm just running it with the original input. Let's see what happens. Quite high. That's not the right answer. Your answer is too high. That's bad. See, like the way he phrased it here, there's, I guess there's something you could do differently than just adding those numbers to the dictionary. But let's see what we're doing wrong. So what are we doing here? If it's on, increase the brightness of those lights by 1. They all start at 0. So that's basically what we do here. It's default to 0, lights point. Oh. We've never decreased. That's why it keeps on increasing. Makes sense. Makes sense. Is that an off by 1 error? Do we count that as off by 1? I don't know. Let's see what happens. Actually, that is the right answer. You know what? Just because I really hate how we did it, I'm gonna move the parsing somewhere else. Let's wait. We're gonna first use. We're gonna parse that. Then we have the range. And for that, we need to know whether, like, the only difference is we have 1 and 3, so we need LED. And range index, and then we say starts with turn, it's 2, else it's 1, and here we're gonna say starts with turn, it's 4, else it's 3. And then we can say commands start range index and range index. Now we're rid of everything else, and now what we need to do is some kind of doing this. So basically we can have a for y and for x. Still not what's where I want it. No. No. Here. So basically I could just say refactor that a bit, and then we say as if toggle. So basically that will make sure that there's a point in it, and if it's toggle and it's not in it, we will be in that case. So we can say, let's quickly copy that over, we can say lights remove, and we can say lights insert, clean that up. And we've removed a lot of boilerplate. Could still move that to proper functions and stuff like that, but I'm not going to do that at the moment. Let's see what happens if we run day 1. We still got the same result. And we could then basically do the same for down here. You could also enhance that a bit and also do them like some kind of strategy pattern if you wanted to, but yeah, it's not worth it doing that in here. So that's how we did day 6. This is quite nice, actually. Thanks for watching. See you at day 7.